Hi, everyone. Thank you for joining us in the Expeditions in Experiential AI seminar series. So I'm John Sujanja. I'm the Director of Responsible AI Practice at the Institute. Today, we have Rupal Patel as our speaker, which I'm very excited about. She's a tenured professor at Northeastern University with joint appointments in Bouvet College of Health Science and Corey College of Computer Science. She's also core faculty in our institute. Her research focuses on speech motor control in healthy talkers and those with neuromotor speech impairment. She's also an entrepreneur who founded and led Vocal ID, a synthetic media company that was recently acquired by Veriton, an enterprise AI solutions company. Her work has been featured on TED, NPR, Wall Street Journal, Wired, many things. So I'm trying to keep the bio too short. We are gonna have the talk and then followed by questions and answers. If you're joining virtually, please start sending your questions whenever you have them in writing. And just to add an information, next week on Wednesday, we are gonna have our annual conference on leading with AI responsibly. And on Thursday, we are gonna have a job fair, career fair at Curry Center for students. So Rupal, and the topic is generative voice applications and implications.
Thanks, Jessie. Hi, everyone. So I wanted to actually start with just a listening experiment, and I actually do not have the ability to connect this computer to the screen here. So I'm just going to play you some samples. I hope you can hear them. What I want you to do is I want you just to listen to these samples and just think about what kind of a voice it is, how it makes you feel, how you would type it, or how you would classify what it sounds like. Okay, so I'm going to crank up my volume. Hopefully it's not too annoying.
Do you want to know the secret to putting extra money back in your pocket? Then switch your car insurance. And now you can make one phone call and shop dozens of insurance companies. Just like buying airline tickets, where it's easy to make one call that has all the best deals. We have great deals with most of the major top-rated insurance companies. We are your superstore for car insurance. We've switched people from their expensive car insurance plans and saved them hundreds of dollars a year. If you think you're paying too much for your car insurance, call now. It's easy.
Okay, number one. Here's another one.
A luxury hotel in Canada has a noble property comprised of tiny houses, each less than 600 square feet. Each unit is connected by an underground tunnel to an expansive lobby and spa facility. The idea is to give guests the feeling of being amongst nature without compromising comfort and style. The views are absolutely stunning and the design is truly remarkable.
Done enough? Okay, that's two. And then I'll play maybe one more here.
Focus. A deep-seated spirit. It's an inner strength to keep your feet planted firmly on the ground, no matter what presses against you. It's confidence. It's belief. It's a way of life. It's nighttime.
Okay, these are all ads. 1, 2, 3. At the end of my presentation, we're going to go back in and we're going to talk a little bit about each of those voices and what you thought. Not only like was it synthetic or not, but also what kind of a voice you think it is. So we'll come back to that in a second. So welcome. I'm going to actually have this talk in almost 2 parts. The first part, I'm going to talk about a technology that was developed here at Northeastern in my lab, and then further I can elaborate it upon and commercialized at a company I started called Vocal ID. And then after that, I'm going to actually transition to something a bit more broader in terms of how that technology is being used in the company that acquired Vocal ID, but also generally in the market and what that means in terms of the kinds of use cases that are possible with this technology and also some of the unintended consequences. So that's kind of like the overview of the talk that I'm going to give. So every single one of you in this room has a unique voice, and our voice says a lot about who we are, how we use our voice, whether we have allergies or not, whether or not we're tired today. There's so many parts of our voice, the sociocultural aspects of our voice, physiological aspects of our voice, and each of our voices changes over our lifetime. So what you sound like today isn't how you're going to sound when you're a few years older, or even if you get pregnant, if you're a woman, that voice is going to change as well. So voice is a very dynamic concept, and each one of us has a unique voice, and they're part of our identities. It's how people are going to remember us. It's how people know us. And yet there are millions of individuals who are living with a condition that is where they are unable to speak. And they're unable to speak for a variety of reasons. They may be born with different kinds of speech impairments. They may actually acquire these speech impairments later in life. And for many of them, when their speech is so severe, they actually have to rely on a method of communication called augmentative and alternative communication, or shortened as AAC. And these devices are ones where they type out their message either with their fingers if they have control of them, or with their eyes, or whatever way they can to actually create the message, and then that message is spoken out loud. If they're using the most advanced technology, they're using something called text-to-speech there. So the text-to-speech synthesis technology for many years was kind of plateaued. It sounded good enough for people to use, and there were a few handful of voices, male voices, female voices, and some children's voices, but not that much variety. So when I started this, research way back in 2002, it was really to say, can we in fact make more unique sounding voices for people who have to rely on these kinds of voices? But it's actually hard to do, right? And even as far back as maybe about 5 to 10 years ago, before the Amazon Echo and Google Home came out, there were really just a uniform set of voices. Even the voices we hear today for devices that talk are pretty generic sounding. They're usually a female, somewhere in her 40s, from somewhere from the middle of the country, right? And typically white sounding, right? And that's kind of the demographic of the voice that you're going to hear. We don't really have a range of multicultural voices. We don't really hear accents that much. And if we do, they're muted down, because the idea is that the message is more important than the voice. And yet the way we interact with each other oftentimes is because the voices are unique, because they tell a story. And yet we try to sort of polish that over when it comes to the media. And the reason why there aren't that many different kinds of voices, at least the reason that was given up until recently, was that it was too expensive to create unique sounding voices. Because the process of creating a synthetic voice was very time consuming and labor intensive. Typically, like the voice created for Siri, for example, took hours and weeks for this person to record all the audio, and then months again for engineers to go over that audio, fine tune the audio, clean it up, and then generate the synthetic voice. And so there has been a legacy of this technology taking a long time and a lot of money to build out. But in the recent, I would say the last 5-6 years, as machine learning technology has advanced, there has been a lot of advances to commercialize this technology and also bring the cost down considerably. So where this all started in terms of taking the work out of the lab and commercializing it was a TED Talk I gave in 2013. I was saying a little bit earlier that I'm tired of talking about this because it's been 10 years now. And I swear by the end of December of 2023, I'm no longer talking about vocal ID. I put a memorandum on it. But what happened in the talk is we talked about, I spoke about the science behind creating a synthetic voice for people who are non-speaking. But the one thing that happened at the end that made it really go out of the lab and into a commercial entity was I asked people, what if you could volunteer your voice for someone in need? We honestly thought a couple of hundred people would say, yeah, I'd be willing to record for someone. Because at that time, we needed about 7 to 10 hours of someone recording for us to then build a synthetic voice. Well, interestingly, we got thousands of people volunteering to say, yes, we want to record our voice. And not just people in the Boston area, but actually people from all over the world. And so they weren't able to come into my lab to record their voice. They had to come up with an online system for them to record. And so that's really the idea of crowdsourcing voices is what started all of this from lab to venture. But how do we, even if people are willing to volunteer their voice, how do you actually make a voice, right? So this is where we have to go back to theory. So there's a theory of speech production known as the source filter theory of speech production. And it says that when someone is talking, there are basically two elements of how voice is created. And this is a very simplified model of speech production. And essentially it's that the voice box vibrates, right? And that's because air is being pushed through it, the vocal folds set into vibration, and that is the source of sound. That source then moves to the rest of the vocal tract, the chambers of your head and your neck. And we shape the head and neck chambers in different ways to produce different sounds. So for example, if I'm producing the buzz sound, I have to put my lips together as this air is being pushed through the rest of the vocal tract, and I hear the buzz sound. If I'm doing pa, there is no voice vibration, but there's still a closure at the lips, and so on and so forth. So all of these changes are happening so dynamically, so easily for you and I, that we don't even think about how all these movements are coordinated together. But when we recorded a microphone, source and filter are captured together. But what we can do through signal processing is differentiate these, pull apart source from filter. And when we do that, we can then recombine source and filter in different ways as well. And so the real idea around the science of this work is that the source characteristics of people who are non-speaking or who have to use a device to talk are relatively preserved, meaning they can make sound. And if they make sounds or vocalizations and people are around them who know them, they know who's making that sound. They might not know what that person is saying because the filter characteristics, the shaping of the lips and the teeth and the tongue and all that, that's what's not capable of being produced in the same way as you and I can. So the filter is corrupted, but the source is preserved. And so what we can do is have people who are non-speaking make sounds. We capture their source characteristics by doing this inverse filtering and separating source from filter. And then we capture the filter characteristics only of the individuals who are their voice donors. And then we recombine the source of the recipient and the filter of the donor, because in digital life, we can do any combination. We don't have to just have source and filter from the same individual. And that was the science behind it, right? As I said, though, to do this at scale, we needed to develop an online system so that people could record their voice and share their voice with others in need. That's what we created, the Human Voice Bank. So the Human Voice Bank was an online website, essentially. It was a web app. And that web app looked like a teleprompter, looked like this. This is actually V2 of the teleprompter, where someone goes in and they have a selection of various stories that they can read aloud. And they're just kind of reading one line at a time. And it's a super simple interface where, you know, there's these buttons here, the stop, back, next, and play buttons map onto the 4 arrow keys on your computer. So that way there's not a whole lot of mousing going on and this and that. You can just easily go line by line by line. And we have line by line because we want to make sure that the person who is reading this work is really only saying what's on the screen, because we're going to automatically then force align this data to use for the data input for the speech synthesis. So stories are usually longer than this. This is actually just a poem, but you get the idea of how that's done. Sorry, that played ahead of me. So how do we create a unique synthetic voice for someone who is like this girl, Maeve? So Maeve was 9 years old when we met her. She had cerebral palsy, and her sister, who was a couple years older, had sort of written into me after she'd watched the TED Talk and said, I really want my sister to have a voice of her own. Right now, she uses an adult female voice, and she sounds like every other kid who is in her school, right, in her special ed class. And so that was one of the impetuses to actually take this out of the lab to say, okay, how can we do this for more than just a handful of people, right? So what kinds of sounds can Maeve make? Well, it was actually one of the hardest things was trying to get someone with cerebral palsy or a neuromotor disorder to generate sound on demand, even though they make sound all the time. They make vocalizations all the time. But when you have to do that on demand, that's actually the hard thing, because it's this motor act of getting that sound and making sure it's not a strained sound. That was the hardest part of what we had to do. You'd think making a database of all these people recording from all over the world, that would be hard, but actually just figuring out how to get a few vocalizations from someone with such severe speech impairment was even tougher. But we managed to do it by using both technology, but also human assisted, kind of had a lot of clinicians involved in this, and so that we could actually get those sounds that we wanted that weren't strained. Because you don't want a strained sound, because then the voice that we're going to build is going to be strained sounding, or like as if it's working too hard. We actually want as natural a voice as possible. So the kinds of sounds that Maeve can make are sounds like this. Is this going through the speaker system, Eric? Is it okay? Can everyone hear that okay? Yeah, okay. So then, so she made a handful of these kinds of sounds, right? We inverse filter that, get the source characteristics. And then her sister
Ice cream is my guilty pleasure.
made, basically she recorded at that time about 3,000, I think it was, lines, kind of like that, where we would again inverse filter that and only take the filter characteristics. One thing I want to share is that there are still speaker identifying features in the filter, and also characteristics of the vocal tract distortion in the source. So you're not completely separating, dissociating them, but we're doing as best as we can in the situation, okay? And then what we're gonna do is we're gonna combine these together and take all 3,000 sentences that Aaron said with the source characteristics that Maeve made, and now this combined core of sentences is going to be fed to a neural net. That neural net is going to train to learn how to speak like that combination.
I can't wait for my friends to hear my new voice. My parents are really happy I'm not addicted to Fortnite. I want to meet Taylor Swift.
Even back in 2016, Swiftie fans were everywhere. And actually, so that's what Maeve wanted to say when she first heard her new voice. So that voice sounds more like the voice of a young child as opposed to the voice that she was using. That is back from in 2016. So it sounds not as good as the voices that we can create today, but I wanted to play you that because as I play you more samples, you'll hear how the technology's evolved over time as well. So now, that voice, once it's built, it's an engine, it's a voice engine. It's a text-to-speech engine that can be downloaded and put into Maeve's device. She uses an eye tracking device, and so she actually uses her eyes to select different words and icons, then those are strung together to make a message. It's a cumbersome process, but now we've actually humanized this device that she walks around with that sounds more like it could have been her voice rather than just some generic voice that several kids in the classroom are using. So that was really vocal ID. This idea of blending voices and creating these bespoke voices, what we were doing in the lab. Once we started commercializing this work though, we also started working with people who were losing their voice. So proactively banking one's voice. And so what you're gonna see in this little video is a gentleman who has head and neck cancer. He found out about 2 weeks before he had his surgery that he was going to lose his voice box for sure, but also about 2/3 of his tongue. And that means that any kind of modification he could make, any kind of shapes he could make with his lips and his tongue were also going to be impaired. And he'd get speech therapy and he'd probably get a little bit better. It's quite amazing what people can do, even with a little bit of whatever is left over with the tongue. But it's a pretty massive surgery. So imagine finding out in 2 weeks, you will not be able to speak. And that during that time, when you're recovering, there's nothing. There's like basically you have to be able to write these notes to each other and things like that. And so what he did is he banked his voice proactively, and by the time he had his surgery, like actually the day he went for his post-op, which was like 2 days later or whatever, he had his synthetic voice on his device that we were able to produce for him. So I'm going to show you the video of him not only talking about the process of recording his voice, but why he wants to record his voice. Just a short little clip.
When I'm going to speak to someone, instead of him hearing, oh, here comes computer one again, they're gonna be actually kind of like hearing what I used to sound like, which is, I think, great technology. It's giving me physically something to do for the future to overcome this.
So what happens is during this period of time, there's like this psychologically, it's such a hard thing to say, in a few days, you're no longer going to have a voice. People are never going to know you in the same way again. So one of the things about recording the voice is it's empowering to say it can live on. And even if you can't use it, or even if you don't use it, let's say your surgery goes perfectly fine. Let's say it's not even as invasive as Lonnie's was. There's someone else that can use it, because in the voice bank, what we were doing was any voice that was shared into the voice bank could be matched with somebody else depending on demographics and age. We don't just use like sisters and siblings and things like that. We were actually matching on a number of characteristics, both demographic characteristics. So if you combine the voice of someone who is 7 with someone who's 70, it's going to sound very weird, right? If you combine my voice, a 5'2" person, with someone who's 6 foot tall, because the vocal tract is so much longer and is so different, you're also going to get a really absurd sounding voice. And so the idea was to have enough diversity in the voice bank so that when anybody needed a voice, we could combine the right kind of voice together. For someone who's proactively banking their voice, though, we can just use their own recordings and recreate the voice. In his case, his voice wasn't as distorted because sometimes people with throat cancer actually have radiation therapy as well prior to this surgery. And in those cases, we sometimes still have to do the combination. So I'm just going to show you what happens, what the process is like for when we're making what we call a vocal legacy voice, is just recordings themselves.
You wish to know all about my grandfather? Well, he's nearly 93 years old.
So he records these 3,000, or it's now like more like 1,500 lines. Same process, no mixing whatsoever in this case, and we just generate the voice.
My family threw a surprise birthday party for me. It was close to 100 friends and family. Most have not seen me since my surgery, but thanks to your technology, they heard me instantly, recognizing my voice.
So this is the 2019 voice. Yeah, I feel like I'm talking about the models of cars, you know, this 2019 voice. Lonnie actually used it for a couple of years until he passed. And, you know, interestingly, his family had become really attached to the voice. So even after he passed, the family continued to actually use that voice as just a memory of him, you know, not like on a daily basis, but one of the things that he really loved to do is like to read stories to his grandkids. And so this was a way, you know, that they would hear grandpa again, it was kind of an interesting thing in terms of this technology. Some people think it's a little creepy, but I think there's going to be people who are growing up with this technology are going to have a different sense of what it means to have the capability to hear loved ones into the future. So it's something that we have to get kind of comfortable with. Like, what is the weirdness about this? Because we look at pictures all the time and we're okay with that, or videotapes. But is it weird that now you can make them say anything? Yeah, it does feel weird, right? So, but just put that in your head in terms of what that could mean in terms of ways that we can develop this further. Okay, so this is now so that's vocal ID. This up until 2021-ish, you know, this is kind of 2020, 2021 is what we were doing. But then what happened is we always knew that the technology that we were developing was only going to be adopted on the masses if there were other use cases. And the only way it could actually be funded further, we were funded through grants from the NSF and the National Institutes of Health, but funding alone of that sort is not going to keep this work going, right? And so we just lucked into this perfect storm that happened in the technology world simultaneously. By the perfect storm, I mean that hardware that was talking became a thing, right? So back in 2017, Google, Amazon all launched their home products, right? And it was the one kind of hardware that was adopted rapidly. So if you think about the computer, the internet, radio, that took years for people to, 20 years for people to have, many people to have those kinds of devices in their homes, right? TVs took about 15 years for most people to have a TV in their home. Smartphones were, before then, the fastest adopted technology in the world, right? And then the smart speaker comes around and almost everyone has one, you know, everywhere, even until we figure out that they're listening to us constantly. So, but anyways, what's really interesting is that this piece of technology was sticky. People wanted this technology around because it was easy. Even toddlers used smart speakers to talk to the device and interact, which had huge gains for children who were sometimes alone and didn't have other communication partners. It was great for people who were lonely and alone. So there was a lot of interesting side benefits of smart speakers, but I think the big side benefit was also for people with disabilities, and also to propel the technology that these smart speakers used, which was speech recognition technology and speech synthesis technology. Additionally, there was this whole voice first software movement that was happening as well in terms of recognition. So speech recognition was funded a lot by the US government in the 80s and 90s. And then when it got kind of good, there was really not a whole lot of work that was happening. But then as we had the smart speaker, we started getting better recognition because you had to recognize individuals even on their phone, and accents were better able to be recognized, and so on and so forth. So there's a massive evolution of speech recognition technology as well, in probably the decade before speech synthesis really has its heyday. And then there's this whole march of how technology is changing in the speech synthesis world. So another piece of software. Way back when we started, even before that, when we started in 2007 or so is when some of the work happened initially in the lab. And we were using a technology called concatenative synthesis, where people record, like I was talking about earlier, you store the pieces of speech as triphones, so 3 sound combinations, and those triphones are kept in a bank. Then when you want to recreate a sound, like let's say if you're going to recreate the word or the name Rupal, you would have to get silence plus ra plus u would be your first triphone, ra plus u plus po would be your next triphone, and so on and so forth, right? And so that's how you would then glue together those little pieces of speech. That's why it's called concatenative speech synthesis. And that was how we created the initial Siri voice, for example. That's concatenative synthesis. That's why it was so expensive, because you had all this data and then you had all this labor to make sure that you were cutting those pieces in the right splice points, because wherever you join them back up together again was where you would hear the abnormalities, right? Concatenative synthesis, unit-based selection was the early work that was done. And then as we start to commercialize, we get the lift also from all these other adjoining technologies like deep neural networks. Now, deep neural networks are essentially just different kinds that each network is paying attention to some other part of the speech signal. It's no longer gluing together speech, it's modeling the speech. So basically, you feed the computer audio samples still. You always start with human audio samples, right? But now the computer is trying to understand what is happening, for example, to the pitch of the voice, what is happening to the frequencies of bands of a voice, and so on and so forth. So it's trying to map for this piece of this string of text, what does the audio sound like? And if you give it enough data, over time, the computer learns that when you write this, this is how it should sound for this speaker, okay? Deep neural networks were a huge advantage to this, because to concatenative synthesis, because it allowed us to have way less speech and still create really good sounding audio. Wasn't as great as what we can hear now, but it was massively important for us to have less audio. Concatenative speech synthesis required 40, 50 hours of speech. We could get away with 5, 10 hours of speech, and maybe even less, depending if there was consistency in the speech. Then there was something called recurrent neural nets, and on and on and on. And now we're all the way out at the generative speech part of it with something called Tagatron. Tagatron is a neural network as well, but it's kind of learning, and it's something called a GAN, which means it's a generalized adversarial network, where every time it gets something wrong, it's a teacher trying to tell the system how to learn better and how to make that gap smaller. I see there might be some computer science students who know exactly what I'm talking about. But with each of these advances, we are seeing different use cases that are being afforded by this technology. Early on, the biggest use case was assistive technology, because there's a big need here, right? But then over time, we get into more of the entertainment use cases, because the voice is sounding better, and now they can imagine adopting it as a replacement or an augmentation to human speech. So I'm going to go into a little bit about like why is this important to media and entertainment? Because what you can do with speech synthesis is with generative synthesis is that you can scale, you can actually create new content, net new content at scale. You can increase the kind of content that you're creating and make it accessible in other languages and so on. And you can also expand into these other markets, right? So these are a bunch of these different companies that we work with at Veritone. And many of them are, because it's a media and entertainment company, but it also has roots also in government and regulated services, but also in HR tech. And so we're kind of doing work with synthetic speech in various areas like this.
Excuse me. Yeah, what are the applications of this technology?
I'm going to show you this right now. Yeah. So in addition to just generating speech, sometimes you can't just plug in an API. You actually have to be able to modify the audio. So for example, let's say you wanted to create advertisements like the ones you heard of before, but you wanted to have components where part of the advertisement was localized to each market. So it's an advertisement, but you're in Boston and you want to say, and call this number, you know, to get whatever your freebie thing is. And if you're in Austin, you want to put some other name or whatever. Even you might even want to change the accent, right? And so what you can do is create that ad. Most of the ad can actually still be said by a human, but the parts that are changing, you can have that person's synthetic voice create all those localization points. And so that's one thing that advertisers are using, right? Where they're taking the synthetic voice of that particular person and using it to localize different markets, right? But you might get things like the name of the town wrong, or you might get things like the street numbers wrong. So this is also being used, for example, in you know what an IVR system is, an interactive voice response system, so phone messaging systems where you call, let's say, CVS, and CVS says, you know, please pick up your medication or whatever. Those messages there, if it's the name of the medication or the name of the person, often it's butchered. And so this kind of UI, this user interface, essentially allows the creative, there's a whole team of voice creatives that actually work on making those samples, and then they can use things like, they can modify the pronunciation of a particular word or a name. They can change the pitch, the speed, the loudness, and all that kind of stuff. So there's an API to this, but there's also a UI, right? So I'm going to show you the tools first, and I'm going to talk about use cases in a second. So we can customize voice, the intonation, the style of the speaking voice, as well as, you know, even the accent. So what's interesting is you no longer need to have the same amount of data for each different style of voice. You can graft the styles as well as the languages. So once you have enough data on one person, let's say myself, even though I don't speak, let's say, Spanish, I can have a Spanish synthetic voice of me that sounds like me, but it's grafted, but my identity is grafted onto that Spanish speaking voice. I can also change the style of my voice, make myself sound Southern, or, you know, whatever. So there's like all these new advances in terms of modifying that voice as well. Okay, so.
Yeah, so I wanted to ask you, like, let's suppose you have a American accent, but you speak in English. But if I want to convert your voice into Spanish accent, can I convert it into the Spanish language as well, or only American?
No, and it's going to actually,
okay.
That's I think you were probably someone that was supposed to ask that question right now, right? Because that's exactly what I'm going to show. This is some work that we did with the podcast. It's a HR podcast, Chat and Cheese, it's called. And what they wanted is they're well-known hosts on this podcast, and they're only in English. They wanted to expand their market. So they wanted their podcast to appear in Spanish, Portuguese, French, and German. And so what we did is took those recordings, took the voices from the English, and then converted them into all of these languages. So it sounds like them, but they're speaking these other languages. And what's interesting is that when you convert a podcast that's 30 minutes long in English to Spanish, if you do just a complete translation, it's going to be longer. There's more words in Spanish, you know, for that same content. And so it's no longer 30 minutes long. So now you have the problem of, oh, now I have a 30-minute long podcast. It's actually 32 minutes or 33 minutes. What do I have to cut? Do I have to speed up something here and there? So that was another problem that we had to kind of go out there and solve, because it wasn't just one-on-one. Because you think, oh, language translation is just going to be the same amount, but it's not, because languages are agglomerative or different in terms of how they actually, how many words it takes to say the same message. So I was going to play some samples, but I'm just going to actually try to see if I can skip a few. Okay, I'm going to skip those. But I can play some samples in a little bit. The other thing that we've been doing is just last year, we started working with Cameo. So if you know Cameo, it's basically a site where you can send messages to people, like famous people can send you a message for your birthday or a greeting or things like that. So when Cameo learned about this technology, they wanted to create a Cameo for Kids line. And they were going to work with a variety of different entertainment companies where their characters are what we were going to replicate. So we were going to make voice clones of these characters, you know, Santa Claus, Coco Melon, if you guys have little kids and things like that. And so we created the voices, we are creating the voices of these different characters, and then anyone can go on the Cameo for Kids website and order a cameo for your child to do things like, you know, brush your teeth, or, you know, here's a birthday wish for you, or let's I don't know, sing happy birthday together, whatever. You can invite your child to do a variety of these different things. I'm just going to play. I'm going to come out of this for 1 second because sometimes it makes me go through the whole thing. I'm going to play you this one here because it's not a good recording, because it was a screen recording of my audio, but I want you to listen to the intonation of Chester the cheetah as he's talking about what he's sending some cameos.
Ladies and gentlemen, cheetahs and humans, it's time to celebrate a momentous occasion. Tura, it's your favorite cheetah, Chester here. Your friend then told me you created the coolest SEB, and that deserves a sprinkling of Cheetos cheer, don't you think? So congrats to the hottest thing since Flamin' Hot. What you've done is amazing. Just like Cheetos, every piece of you is unique. Keep leaving a trail of Cheetos goodness wherever you go. Take it easy and keep it cheesy after
Okay, so not a great audio recording, but you can kind of see this, it's getting so much more expressive. Also, what's interesting is the animations are timed with the way that the pitch is going up and down and so on. I'll play this other one. I don't like sound. We don't need to think about Santa yet, but here's Coco.
Hey friends, it's Cece from Coco. I'm so excited to be on Cameo to share holiday cheer, birthday wishes, or a little pick-me-up. I'm here for you. Request a personalized message from me today.
Okay, so you get a sense of sort of like what these people are, what the kinds of different things that entertainment companies are doing.
Ladies and gentlemen,
no.
cheetahs.
Sorry, no cheetahs. I'm not going to play the samples. I'm just going to keep it on this screen as well. This is a live sports commentary. So there are some companies out there where if you like to watch sports that aren't really televised here, sometimes you can see just the moving ball, or the you know, like where the position is of this ball, or who's at bat, or whatever, like just on a screen. There's no commentary whatsoever. So we worked with this company called Stats Perform, where they have the live stream of like where the ball is, where the players are on the screen, and then we use synthetic characters to commentate and to do the whole commentary, the narrative, their narration, using the synthetic voice based on the positioning of where the ball is or the puck is or whatever on the screen. So it's generative commentary, and then taking that generative commentary and turning it into voice. So now, what does this mean? Well, first, I think there's lots of opportunities. We've talked about some of the use cases and so on, the cross-lingual communication, democratizing who's heard. I think that's going to, you know, I do think there are markets of voices we don't hear at all. And it would be fantastic to start hearing voices like that, and groups of voices like that. And there's also going to be, you know, new market audiences that we can reach with technology in the education sphere and other places where people aren't really hearing the kinds of voices that they would want to believe in, right? The challenges, though, are the data set ownership challenges, like who has a right to this voice? If my voice is recorded for a talk, can someone just take that voice and start creating a synthetic voice clone of it? There's so many companies now that do this. In 2014, I started the company. There was nobody really creating any synthetic voices, you know, certainly not at scale. It was like 150,000. So hackers didn't really have 150,000. That was the cheapest voice you could build at the time. These days, you can go and record for 3 minutes, and you will have a voice in a few hours, right? So it has changed dramatically. Provenance is who is the rightful owner of that voice? What is the source of that voice? Fair use and rights, and who has responsibility over that voice is really important for voiceover actors. There's people that do this for a living, and for them, it's really, really important that their voice is regulated and that they get the actual royalties from that. The interoperability of the voices, like where can they work and how can they work, is also another challenge. And then, of course, what are the regulations that are going to happen? Hopefully, these regulations happen in tandem with the people that are working on the technology, and so we don't completely, squash innovation. But it is kind of a challenge these days. I think the biggest challenge is the the unintended consequences. So even though this, we set out to do this work for a very good cause, there are many unintended consequences today as the technologies evolve. And with many technologies, that does happen, right? There are going to be bad actors. There are going to be ways that this technology is going to be abused and used. And so some of the work that we've done, in fact, in 2018, we were approached by a bank to see if we could hack into their system using our synthetic voices. And when we showed we could and said, it only took about 100 sentences for us to build a voice to hack it, which we actually didn't think that we could do it back in 2018 when the voices didn't sound as good. And they said, yeah, well, there's insurance, we can deal with it. But just this morning, I had a call with a company that is doing that work now of detecting deep fakes and deep audio fakes and so on. And there's more fakes out there. There are more companies that are listening, and there's more actors, I think, that want to be able to figure out better uses of their technology as well. So there is this evolution together, I think, of making sure that we do not fall into the trap of thinking that this is not going to get abused, because every technology gets abused. This is not going to be one that, only good people are going to use this technology. There's always going to be unintended consequences, and we can foresee them. There's no reason why we shouldn't be working now to foresee those and mitigate those. And so one thing that's being done is putting watermarks or different ways to put things into the signal. But it's not just about technology, it's also about regulation, it's about business practices and all of that together. So I'm going to just end with a few takeaways. Research innovation, I believe, oftentimes is going to precede the market demand. So what we do here at the university and other research labs is stuff that is not necessarily always that there isn't a market pull for it, but it is where it begins, and I think real life use cases, especially for people who are disadvantaged, may have disabilities, maybe niche groups in some sort, but that's actually where innovation is needed the most. And that if we start there, so many discoveries, so many things that we all use, everybody uses. So for example, the earphones that we use today, right, that everyone has in their ears constantly, that has taken so many years to evolve, because initially it was people who wore hearing aids who had to be fitted with in the ear hearing aids, and people were putting them away. They were putting them in their bedside drawers. Why? Because they didn't fit and they didn't feel good. They were hard. It's that piece of plastic. It didn't matter if that technology was thousands of dollars. People were not willing to wear them because they hurt. A simple thing like that. And then we started creating softer, more molded hearing aids and so on and so forth. And then that meant that you and I could also enjoy them while we were running, whether we were walking or, in windy situations, whatever, right? So if we start with important use cases, we will get to technologies and innovations that everyone can use. And that's how sort of the market evolves as well. Automation and scale will require that broader automation, will require that broader market adoption though, because we can't really improve things for small markets because the margins are not there. That doesn't mean we shouldn't do that. And that's why we have innovation, projects and innovation grants like SBIR that kind of help us do that. And we talked a little bit about this unforeseen consequences and so on. The last point I want to make is that accessibility. I think we've been talking so much about disability and awareness and thinking that, oh, this kind of work is only for people with disabilities and this stuff is for people with abilities. Actually, when we work on accessibility, we're in fact working for everyone. And so I think if we reframe the conversation around technology as accessibility, will actually probably improve the lives of not just everyone who can benefit from this, but anyone who right now is using something that is kind of like a makeshift kind of solution where they really deserve something that is far more intricate and far more developed that considers the human model. So human-centered design, I think at the end of the day is what hopefully we can get to. So I think with that, I am going to end. And I just wanted to go back to that quiz of the sounds that we heard at the very beginning of the presentation. How many of those were real? How many of those were synthetic?
Can you please play it again?
Yeah. I have to remind myself which one I played.
Do you want to know the secret to putting extra money back in your pocket? Then switch your car insurance. And now you can make one phone call and shop dozens of insurance companies. Just like buying airline tickets, where it's easy to make one.
So that was one. I think this was the second one. Oh, no, that was not the second.
A luxury hotel in Canada has a novel property comprised of tiny houses, each less than 600 square feet.
2 and 3.
It's a mindset, a focus, a deep-seated spirit. It's an inner trance to keep your feet planted firmly on the ground, no matter what presses against you.
Yes.
Oh, no.
All of them are synthetic? Am I giving it away? Actually, the first one was not synthetic. Really? Yeah.
Oh.
But and that's actually, so we did make a synthetic version of that as well. But it's really hard to tell. So back, a few years ago, you would play those, and those half the time, I mean, if it wasn't me giving the presentation, if someone was just like giving the presentation, they'd be like, oh, it's 50%. You really wouldn't have much of a chance. But these days, I think that line is getting more and more blurred between them. So I do have 14 minutes. Eric was told me I had to have 15 minutes for questions, but I have 14 minutes for questions. So I'm happy to take any questions you may have about any of this work.
So whenever we are getting these recordings, so for example, we took the example of the two sisters, right?
Yeah.
Both of them are pretty young.
Yes.
Is there a way in which we can like evolve our voice in terms of how it grows with age?
Great question. Can you age the voice?
Yeah.
Yes. We actually have a patent on how to age the voice. And so you can age a voice. So we kind of considered the voices within 4 age bands. So we thought about a young voice, child voice, an adolescent voice, because there's a lot of change in the adolescent voice, then an adult voice, and then a mature voice. And so within those age bands, you can modify the voice, algorithmically to kind of change a little, grow.
Right.
But as you move from a child voice to an adolescent voice, for example, that jump is really just too big. And so if you try to do it algorithmically, what ends up happening is it just sounds like there's too much artifact in it. It's not about being fake, but it just kind of, it cracks, it breaks, it doesn't do what you want it to do. So there you would actually start with a new voice donor, and then you would do the cycle again. Yeah.
Does in your example, does May's voice, like while feeding the voice to the neural network, are you feeding both the voices or only the original voice of the May?
Oh, good question. Okay, so when you are making the bespoke voice, you first do the inverse filtering on the source and on the filter. So both recordings of the recipient and the donor, and then you take only the source characteristics of one and only the filter characteristics. So it's like mixing the egg white and yolk from 2 different eggs. And then when it comes together, those recordings that are modified are the ones that are fed to the neural network. So now the neural network learns to talk like those modified samples.
So your features would be extracted from the
donor voice.
Donor voice.
Yeah.
And you spoke about interoperability as a big challenge. How, what are the exact challenges with respect to interoperability in the voice?
The biggest thing is what operating system it's running on. So for example, our voices, we have to package that voice engine up so that it could run on a Windows system, right? But if you wanted to run that same voice on an iOS system, the iOS system, you have to actually integrate with the app itself for that voice to run. In Android, it's easy. You just point it at that engine and it's fine. But for iOS, it's still a challenge.
Is there any domain-related interoperability challenges you are facing? Let's suppose healthcare related voice generation or edtech related voice generation, or
no, it's more actually on the it's actually not as much of a problem now, because most companies now are using web-based services to to use the engine. But if they have to have an on-prem system, you're still back at the same problem. So the problem with the assistive technologies is they're all on-prem. You had to make it on-prem because the devices they're typically locked from being internet ready. And so you had to put that same engine on the person's device. And so that was one of the biggest challenges then, is that even though better technology, and it's still actually a challenge right now, even though we can make better sounding voices, those better sounding voices only work in the cloud, or not only work in the cloud. They're so big that they actually have their cloud instantiated, right? And they won't run on those people's devices. And so we still have to give them like a generation or two older technology.
One last question, like, sorry. So it would be, how has LLMs like affected your voice generation or something?
So I think LLMs have, they don't affect voice generation, but what LLMs have done is made it super easy to create new content. And now basically it's like having more to showcase, right? So before you had to have someone write a script or, take content that existed and then turn that into a voice. Now, I mean, you could have an LLM that is telling jokes, or whatever. And like, it's constantly feeding the content to the speech synthesis engine. And so speech synthesis just becomes an even more needed thing, because if you want the output of the LLM to be heard, you have to use synthesis. So it's kind of a little bit like the fact that a smart speaker allowed sound to be heard, beyond just on a computer. Now the LLMs are saying it allows content to be audible. Yeah. Other questions?
I have a question about kind of what you were talking about at the end in terms of some of the kind of future challenges. And I was wondering if you could talk a little bit more about what currently regulations or whatever is in place to protect people's rights to their voice and things like that. Like how does that work right now? Is it just sort of a free for all at the moment, or are there any kind of constraints and rights that people have right now?
So Europe is way more ahead of us than we are. I mean, there's, with all of the GDPR rules, voice is a identifying piece of material, right? And so it's called personally identifying information, right? And so the hard thing is that the ownership of the recordings is pretty clear. The recordings ownership is the individual, right? But what happens with the synthetic version of that, because now it's not just the individual's own system, like their own body producing this voice. It's like, there's IP that's involved by the technology company and so on and so forth. So that regulation, it's unclear really. Is the voice model owned by the company? Is the voice model, is the company in some ways responsible to share that revenue with that person whose voice it is? And that's also why there's sort of similar to images. You know how people are making image banks and so on and so forth. Who owns those images? I think it's fuzzy. It's really still pretty undefined because there are multiple ways is this being processed, right? So it's like, does the sugar manufacturer actually have rights to the candy that's produced? Or is that just an ingredient to making that? That's also why many companies are starting to talk about generative voice, where they want to create samples that are mixes of multiple people's voices, because you can't really say it sounds like Kristen anymore exactly. So is it really her likeness that we're selling? It's the slippery slope though, right? And I think that's the tricky part it's happening in audio, it's happening in video. Even in video, right? You take all these people's images and then you can create faces, even dating profiles or whatever. They don't really look like you. They kind of look like you, and there are 5 different people's faces, best done. Whose is that? So that's why I think the protection and the bringing awareness to what this is really, really important. And I'm actually going to plug, we have another event next week. I've been working with Joanna and Michael and a few other people, and Jonathan, who are all part of this new initiative that we have called AI Literacy Lab. And we want to get more people to understand what AI is, not just the fear factor, but also really about what I talked about today. What are the opportunities? And we want journalists and scientists to talk together to get away from just the hype and fear conversations to really kind of what could this be used for? How do we mitigate it? And what are the important questions that we have to wrestle with as we think about evolving with this technology? So that's next week, and it's combined with the event that Johnson talked about at the beginning as well.
One more technical question. How are these models evaluated? Like on what metrics?
They're evaluated on, so they used to be evaluated a lot on the understandability, but understandability has kind of maxed out now. So we kind of know that. Usually it's tests like the preference of the voice. You know, do people prefer this one voice to another? So it's listening tests usually. Doing a test like, so most of the stuff that was done before was the understandability of the voice as a percentage accuracy score. It's like 99 point something, it doesn't matter anymore. It's more about, does it fit that use case or not? So if it's an advertisement, how many people clicked on it? And do they care whether it was synthetic or human or not? So it's more proxy kinds of assessments or outcomes. I do want to actually, talking about that makes me realize one thing is when we were making these bespoke voices, we were determined as scientists, like the voice has to be accurate. It has to sound like it belongs to me. It has to sound like it could have been her voice, right? We're really going for accuracy. Like, could this be the voice of an 11-year-old or not? And so on and so forth. And is it really doing the blending properly and making sure it's more about the source characteristics and not about the filter characteristics? And as we started, you know, delivering these voices to people, people would say, well, that voice doesn't really sound that, you know, assertive, or my child is a lot, you know, more confident than that voice sounds, or, you know, like all of these other sound, like other kinds of adjectives that are like, what the heck is, you know, what is assertive in acoustic terms, or what is, you know, confident or stronger. And so I think one of the biggest things that we learned was that accuracy is important. You can't be completely in left field, but preference is even more important. And this is a lesson that actually that has been a lesson learned even in video or in film, right? So Polaroid and Kodak fought over this. One went for accuracy and we looked green in those pictures. And guess what? People didn't like that, right? And so, you know, and the other went for preference, right? And so preference at the end of the day, one of the things that I think we get really carried away with in the science of all of this is we're always looking for accuracy, but it's the combination where there's a sweet spot between preference and accuracy.
Just to follow up,
Yeah.
I was curious if you could comment on where the field is on adding affect and prosody and some other tones to AAC devices and speech generating devices in general.
Well, where the field is in AAC is different from where the field is in general. Yeah. So in the field in general in speech synthesis, I think there's tons more prosody these days. There's affect, there's ways to modify the voice, as I was showing you earlier, and also styles, and that's just evolved radically. Unfortunately, in the AAC world, in the assistive technology world, they're still relying on older technology, partly because of the hardware, partly because there is monopolies on which technology can be used on which devices. And so it just needs to get redone, but it's such a hard market to, you know, to try to break open. But I think that there's more of an understanding that there is a need for prosody. I think that information transmission is valued a lot more than the feeling, the emotion, which is unfortunate because no matter what, at the end of the day, it's the feelings that people remember and not exactly the way that you said it. The grammar, nobody could care less for. I think if you're communicating really quickly and you have to get your message across, it's the affect that's actually going to matter more for these kids and adults who have to use these devices. But it's not the way we're evaluated. It's not the way it's evaluated. I hope that their LLMs can do something where they interpolate in between for people, like after they put in the various different icons, that there could be more complete sentences, and maybe there, as the content becomes more sophisticated, that people can string together, the perception of cognition, the perception of awareness in this group will also be greater, because I think that's part of what's holding it back. I don't think it's the full answer, but there's so much we have to do to kind of break out of those silos. But again, I think every new technology advance we can make is going to have some benefits on that population, I think. Yeah, thank you.
Yes, so you talked about preference versus accuracy, and I'm super interested in listeners' parts and for researchers who are probably gonna explore new user cases in the future. What do you maybe recommend for researchers to use this technology to develop not technology, but maybe develop new therapeutic therapeutic methods?
Yeah, I'll give you a really simple example. Is like a lot of the therapy tools right now tend to rely on whatever synthetic voice is available, you know, generic sounding voices. And part of the excuse that they'll give is, well, it's understandable. You know, it's the most understandable. It's got no accent whatsoever. And it's, you know, perfectly. But I think if we could do experiments to show that, you know, listeners don't always need to have an unaccented voice to understand it. And that some groups of listeners might in fact prefer a voice that's familiar to them, that feels like it's from their community, that is actually one where they feel trust with it. And so I think one of the biggest misconceptions is that what is the average and what is sort of, I don't mean this in a bad way, is like sort of, is not going to be offensive, isn't going to hurt anybody's feelings, is not going to be refuted, is what we need to go with. But unfortunately, I mean, I think if you think about education as well, if you had educational toys or applications where the synthetic voice is doing the, you know, part of the instruction, if those samples of those voices were different, they represented the people around us, they had accents, they did all these different things, I think more people would use them. And I think that could make it be fun that way as well to engage with them. So I think those biases take a while to remove, and I think people need to study them, because I think it's just sort of easiest path is to use whatever is just readily available.
Are there any open source voice things?
There's so many now. There's just so many. I think many of them are also like many of the kinds of voices that are available. Like there's, you know, Google, Amazon, all these also have, Microsoft also have a ton of different voices. And there is more variety there too now than there was before. And it's so cheap. All right. So it's like 1 million characters for $16. You can, it's really not costly whatsoever anymore.
Thank you, Rupal.
Yes,
we are going to have to end now. I think if there are more questions, I'm going to tell them to catch you.
Yes. Yes. Thank you very much.
Thank you so much.